How to understand rotation of a shape? Step 1. Understand what rotation is. Rotation is a type of transformation where a shape turns around a fixed point without changing its size or shape. The fixed point usually is the origin 0, 0 or another given point. Rotation are measured in degrees and follow these rules. So 90 degrees clockwise is the same as 270 counterclockwise, and 90 degree counterclockwise is equal to 270 clockwise. 180 degree is the same in both directions. Step 2. Rotation rules around the origin. So when you are rotating a shape around the origin, you can use a formula by just switching the points. Here, for example, you have rotate A 3 to 90 degrees clockwise. So what they did, they applied the formula here. So you have the order, so you have the normal point, which is 3, 2, and then afterwards all you have to do right here is to switch the points. Like this is X and this is Y. So what you did to get the answer is to switch the points. So you get 2, 3, and the X is negative, so you put a negative here. So that's why they end up with 2, negative 3.
In this video, I'm going to show you an easier way to rotate a figure about the origin 90 degrees, 180 degrees, or 270 degrees. So what you would do is you would draw your pre-image, like I've drawn here, and then what you would do is you would take the figure and rotate it. So for example, if we want to rotate 90 degrees counterclockwise, I would go ahead and take this and rotate it a quarter turn to the left. And then what you would do is take like another sheet of paper, and what we're going to do is we're going to now record the location of the points as they stand now. So for example, A prime is going to be -1, 0. B prime looks like it's at -1, -2, -3, -4, 2. And C prime, you're at -1, -2, 1, 2, 3. Okay, now what you want to do is you want to take the figure and rotate it back into its original position. Okay, and now what you want to do is plot these points on the diagram. So -1, 0 is going to be here. That's our A prime. B prime is at -1, -2, -3, -4, 2. That's our B prime. C prime is at -2, 1, 2, 3.
And if the question might be worded as follows. Rotate shape A 90 degrees clockwise about the origin, label the image B. Once again, we'll start with a piece of tracing paper. We'll trace around the shape, and then we need to place the pencil at the point we're rotating around. Now this time it hasn't been marked onto the grid, we're going to have to mark it on ourselves. We've been told in the wording of the question it's about the origin. The origin is the point 0, 0, so we mark on that point ourselves. Then we place the pencil on this point and begin to turn the shape. This one's 90 degrees clockwise, so 1/4 of a turn in the same direction that the hands on a clock move, so this way. We can then lift off the tracing paper and draw the shape in this place. This question says to label the image B, so let's write a B onto the shape. Now let's...
Step 3. If the center of rotation is not 0, 0, you have to use this approach. You have to subtract the center of rotation coordinates from each vertex, and this makes the rotation point temporary origin. Then you apply the rotation rules. After you do so, you're going to translate back to the original position. Since we shift the shape earlier, we add back the original center of rotation to the final position. After you add it back, you plot the new points on the coordinate plane.
In this lesson, we're going to talk about how to rotate a point about another point, which is not the origin. So you learned previously how to rotate 90, 180 degrees, 270 degrees counterclockwise about the origin, but now what we're going to have is a new center of rotation. We're going to go through 3 easy steps that you can apply. I'm going to try to show you why it works in this first example, and then we'll do 2 other examples where you can practice on your own if you like to get some more experience. And then at the end of the video, I'll show you where these 90, 180 degree, and 270 degree rules come from if you want to understand that more deeply. So for the first example, we're rotating point P, which is at 2, 5, about the center of rotation 1, 3. We're rotating at 90 degrees counterclockwise, so that's going to be like this. So what we want to do is, the first step is to subtract the center of rotation from point P. So what we're going to do is we're going to take our point, which is 2, 5, and we're going to subtract the center of rotation 1, 3. And 2 minus 1 comes out to 1, and 5 minus 3 comes out to 2. Now, you're probably saying, well, why are we doing that, right? Well, imagine if your center of rotation is like your new origin. Okay, so I'm drawing in a dash x and y axis there. You can see point P is really like right 1 up 2. See how we have 1, 2? So now what we're going to do is we're going to apply our rotation rules, in this case 90 degrees counterclockwise. xy becomes negative yx. So the way I like to think about it is you switch the x and the y, and you make this new x value the opposite sign. Okay, that's how I like to think about it. You switch the x and the y, the new x becomes the opposite. Okay, so now we're at negative 2, 1. So from this perspective, you can think about this is like left 2, up 1, and you can see how we've rotated that 90 degrees. I'll even draw in some more dotted lines, see that right angle. But then what you want to do is you want to add back the center of rotation to this new point, negative 2, 1. So if we do that, our center of rotation is 1, 3, negative 2 plus 1 is negative 1, and 1 plus 3 is 4. And look at where this point is right here. You're at left 1, up 4, and that's exactly where the point is located. So 3 easy steps. Let's try another example. See if you can practice this one on your own. Okay, example number 2. See if you can pause the video and try this one on your own. We're rotating this point 1, 4, 180 degrees counterclockwise, or clockwise, doesn't matter because 180 is a half rotation, half turn, about the center, the new center of rotation, which is at 0, 2 right here. So go ahead and try that one. Now, if I was going to do it, what I would do is apply these rules. The first thing would be to subtract the center of rotation from our point. So I'll just label these steps. So step 1, we take 1, 4, and we subtract 0, 2. So that's going to give us 1 minus 0 is 1, and negative 4 minus 2 is negative 6. Now, to try to understand this a little bit more deeply, we can think about the center of rotation as like our new origin, right? So we kind of have a new origin point right there. And when we're subtracting 0, 2, okay, what that's basically doing is it's taking the center of rotation and it's moving it back to where the origin is, okay, where our normal origin is. And so then what that allows us to do is to apply our rules, just like we normally do when we're rotating about the origin. So you can see this point 1, 6, from the perspective of this new center of rotation, we're at right 1, down 6. See, there's our point as if that was the origin, right? So then step number 2 is we're going to apply the rotation rules. Now with 180 degrees, all we do is we keep the x and the y in the same order, but we make them the opposite sign, okay? So what that's going to be is now for step 2, this will become negative 1, this will become positive 6, so the signs flip. So negative 1, 6, what does that mean? Well, basically what it means is that from this center of rotation, this new point, if we were to go left 1, up 6, that would put us right here. So you're basically turning, let me see if I can draw a dotted line here, you're doing like a half turn, and you can see this point is ending up right there, rotating or pivoting about this new center of rotation, right? But then what's going to happen for the last step is we're going to add back the center of rotation to that point. So for step 3, we're going to take negative 1, 6. We're going to add back 0, 2. So negative 1 plus 0 is negative 1, and 6 plus 2 is 8. And you can see that that's where our point is located from the original 0, 0 point, the original origin, left 1, up 8. Now, why are we adding back that center of rotation at the very end there? Well, remember originally we subtracted it, okay? So that basically brought this point to the origin. Now, when we add it back, we're putting it back to where we started, right? So it's just like a translation. Like if you're sliding everything down to, which is what we did here originally, then we rotated, then we had to move everything back up to put it into the, to the final position there. So
we're going to rotate this 90 degrees around the point 2, 1. So here's the way that this one looks. Instead of me having my point, okay, at the origin, my rotation point, I'm going to move over to 2 and up by 1, and I'm going to place it right here. And so what that means is that the circle, let me get my little circle tool here. Okay, my circle is actually now centered right here, and I'm going to travel around this circle in some way. So these points are going to travel around this circle instead of traveling around the original one, which was kind of centered over here at the origin. So by changing my center of rotation, I'm actually changing the circle that they're traveling around. Okay, and so here's what we're going to do. Let's pull our points off of the graph so we know what we're working with. It looks like I have an A value, okay, of negative 1, 2, 3, 4, negative 4, negative 1. Okay, I have a B value. Okay, oh, let me give myself some space here. We're going to need a little bit of space. Okay, B value of negative 3 and up to 1, 2, 3, 4, 5, negative 3, 5. Okay, and I have a C value of, it looks like negative 1, 3. Negative 1, positive 3. Right? So what our rule here said was if we want to rotate this, let's subtract the point of rotation off of each vertex point for my shape. So let's start with that. So my point of rotation is 2, 1. So they're asking us to subtract 2 and subtract 1 from each of these points. And what that's doing is it's kind of shifting the entire graph over 2 units to the left and down 1 unit, which is going to move my center of rotation to the origin. So here's why kind of like interim point, I'm not even going to call it A prime because it's not A prime yet. We haven't done our rotation. So if I do negative 4 minus 2, I get negative 6. Negative 1 minus 1, I get negative 2. Okay, and then I'm going to do that for each of these points. It looks like I get an interim point of negative 5, 4. And my C is going to go to negative 3, 2. Right? So again, that's just kind of taking all these points and sliding them to the left by 2 and down by 1 so that my center of rotation can be at the origin. So we're going to perform our rotation algorithm on these points here, these ones that I've slid over and down. Okay? So if you remember the rule again that we had for a 90-degree turn, okay, switch the sign of y and then swap the x and the y values. So that's the algorithm that we're going to apply, that we can apply now because now my center is at the origin. So I'm going to switch the sign of y, which would make this positive. Okay, so this one I'm going to call it A. Okay, call that A prime. Okay, so I'm going to say my A prime is going to be positive 2, okay, negative 6. Oh, actually, you know what? I'm not going to call this A prime yet. We have one more step left to do. So let me get rid of that. Okay. So this is kind of another interim step, okay, where I'm going to take my point and do the rotation. Okay. So I did my algorithm where I put on I switched x and y and then flipped. Let's do it again on this new B value. Switch x and y after I've changed the sign of y. So this is going to become negative 4, negative 5, right? And I have one more rotation left to do. This is going to become negative 2, negative 3, okay? So now, to get back to my final step here, so that was my rotation as we would around the origin. I used my 90-degree rule, and I rotated around the origin, but now I got to move all my points back, okay? So I'm going to add in that 2 and that 1 that I took away at the beginning. So let's add 2 and add 1 to each of these points. Plus 2, plus 1, plus 2, plus 1, right? So now here's my final rotated points. This, let me use another color here. This is my A prime. This looks like 4 and negative 5, okay? This one looks like negative 2, -4, and I'll call this one B prime finally because I've done my rotation. Okay, and then my C prime, I'm going to call it looks like 0. Okay, and this looks like -2. So let's plot these points and see what it looks like. Okay, so my A prime is 4, 1, 2, 3, 4, and down 5. 1, 2, 3, 4, 5. That would be right here. That's A prime. -2, -4. 1, 2, 1, 2, 3, 4. That would be this point. Okay, and C is at 0, -2. There's my C prime. So let's graph or put lines through these points and see what happens. Okay. So again, the idea here is that we actually rotated around this point, not the original one. So let me see what happens, what it looks like when I draw a circle centered at this point right here. Okay. Oh, it didn't work. Let's try again. Okay, centering at my point here. Let's see what happens. It's being a pain to me. One more time. There it is. Okay. So if you notice, my original C traveled along that circle, and it's still both of the points, my original point and my new image point, are both along the circle. If I expand out so I can hit B, both of my B values and my A values are also traveling along a circle that is centered at that point. So if you notice, I'm using that circle at 2, 1, or 1, yeah, 2, 1, and I'm traveling around circles that are centered at that point. But in order to get that, we kind of have to slide it over to the origin, do some work on it, with our origin rules, and then we got to slide it back so that it's centered where we would like it to be